So f of u over n is that. And again, this thing just depends on the molecular structures. And I've just taken the sum and defined everything except for the coefficient n as f of u over n. Okay, plus this thing. So now I need a sum on j, njr. So instead of n, I have an nj times r times the log of n0 over v0. Well, they all have the same n0 and v0, so that's easy. Divided by n over v. Okay, so I need to manipulate that n over v. Well, n now should be nj over v. So I should just have nj over v. There's no j on the v because they all have the same v. So what I should have in here is nj over v. And I'd like to sort of play around with this nj over v and get it into another form. Well, nj over v, just so because these are ideal gases, nj over v, and it's an ideal mixture, is just pj, the partial pressure of P, over RT. And pj is just P total times nj over n. That's the partial pressure of J. Okay, so wherever I saw nj over v, I'm going to stick this in. So now I'm going to rewrite this term. So this term is now sum on j, njr log. So I have n0 over v0. And now where I have an nj over v, I'm going to plug all this in. So I've got P over RT times, so then I'm plus log nj over n minus log nj over n. Because I should have had an nj over n here in the denominator. Instead, I moved it into another log with a minus sign, so I stick it in the numerator. Is that clear? Okay. And I can do the same thing for u. U is equal to the sum of nj over n0 times u0 plus something plus the sum on nj of the integral of cv at of t prime dt prime. Because cv dt and cv dt is du. Are you with me? Or against it? Okay. So now let's go back to the first law. This was the first law for a single component. Now I need the first law for multi-component. First law for multi-component mixtures says du is equal to TdS minus PdV plus the sum on J, uj dnj. When I have multi-component systems, I've got these mu's and dn's. You remember that from thermo? Okay. So now, if I want to come up with an expression, remember the next thing I need, I now have S mixture, now I need mu. So if I want uj, I get that from the first law, uj is just du dnj at constant S, V, and all the other k's. So that's equal to du dnj at S, V, and K. So I hold S, V, and all the other n's constant. Thermo is the only place where when I write a partial derivative, I got to tell you what's being held constant. Usually partial derivative means you hold everything else constant. But there are so many different ways of structuring everything else that I have to say that, write that explicitly. Okay. And you can transform this by Maxwell's relations to du. Now it's hard to keep S fixed, so that's why I wanted keeping something else fixed. So by Maxwell's relations, we can derive this du dnj at Vt and nk, T, V, and k. So I want to change variables from S to T, change dependent variables. And I do that by what's called Legendre transformation. And then I find that when I change from S to T, I have another term. And the other term is minus T ds dnj at Vt and k, Tv and k. And that happens when I write an expression for u, instead of in terms of ds, I want to write it in terms of dt. So I need to get rid of the ds in favor of dt, and that requires adding some stuff. And then that ends up giving me this extra term when I solve for it. That's a little more thermo-y, so I'm not going to do that in class, but I can always do that for you outside of class. Okay, so now let's calculate this, because we have expressions for u and we have expressions for s. Here they are, so we can calculate these partial derivatives. How are we doing on time? All right, we only have like 20 minutes. See how far we get. Is your watch correct? Or is it fast? Okay. We started, what time did we start? We started about 20 after, by the time everyone was here. All right, so I won't go past an hour and a half. I think we started about 20 after, so we'll go till 10:02. Okay, so uj is equal to, so I need the udnj. So from here, I just get udnj is u0 over n0. Just make sure I'm taking the right derivative. Yep. And ddnj here is, here I have plus the jth one, this is j. The integral t0 to t cv j hat of t prime to t prime. Okay, plus or minus. So that's this. So here I kept t fixed, the volume is fixed, and I kept all the other ends fixed. So the only thing that changed is one end. So I only got one term there. And now I need t ds dnj. So I need to take d dnj. So minus t times d dnj of this is just s0 over n0. This should have been a u0j. This u0 belongs to each individual component. And the CV has the j on it. Okay, so now I need to take the s dnj. So I took the derivative of this one. Now I need this. So now I need to take d dnj of this, and then d dnj of these guys. So let's take d dnj of this. N is the sum of the nj's. So when I take the derivative, I've got an nj in here, and I've got an nj in there. So first I'll take a derivative of this. This is just the sum of the nj's. When I take the ddnj, I just get 1. So I just get an f back. And now I have an n times the derivative of this. this is f prime, times the derivative of this thing with respect to nj. Well, there's an nj in the denominator. So I've got u, so I have minus u over n squared. So I've got the u just comes along for the ride, and I've got the derivative of 1 over n. Derivative of 1 over n is minus 1 over n squared. Times the derivative of n with respect to nj, which is 1. That's that term. And now I've got these two terms, which I separated out. And now you can see why I separated them out. Because I want to take a derivative with respect to nj. There's no nj in here, but there is an nj in here. So that's why I separated this into two terms. So the first one is I have an nj here. So this gives me just r log n0 rt over v0 t plus r log nj over n plus, now this thing times the derivative of that. So I've got njr. Well, this doesn't depend on nj, so I just have this. So I need the minus sign. And this is the log of nj minus the log of n. So the n doesn't matter. And the derivative of the log of nj with respect to nj is just 1 over nj. So if I haven't made any mistakes, that's the result. Let's just check. Okay, so by the way, and let's factor out an RT. So I have uj is equal to RT times U0j over N0 RT plus the integral T0 to T CVJ hat T prime GT prime over RT minus, and now I'm going to distribute the minus inside. So I've got a plus 1. So here I have RT minus a minus divided by RT is equal to 1. So that's this term. And now I've got this term. So I've got minus S0J over N0R minus F of U over N divided by R plus, I factor out an R, so I multiply and divide by R, that's correct. So now I've got N, so I've got a minus is a plus. So I've got U, I've got an N canceling, and I've got a U F prime of U over N over NRT of NR. U over NR. And now I've got these things, these two guys. So these two guys is I have a minus, the RT came out, and I've got the log of N0 RT over V0 T. I think I lost the sign here, or is that correct? Yeah, this is negative. Came right from there. NJ over. And that's all the terms. And except I lost, no, the RT is correct. Okay. So what do I want to do with all this? And remember, this whole thing, N0 RT over P, V0 NJ over N, is just N0 over V0 NJ over N. This whole thing is just this. So I'm going to write it this way.